Hi dears, how you are? Hope you are safe at home. Welcome back to social science class. Children, in the previous class, we have completed the geography first lesson, seasons and time. Today, let's moving on to the second chapter, in search of source of wind. Are you ready? If you are ready, let's start. 8 July 1497, Vasco da Gama started his voyage in 4 ships from the port of Lisbon with a crew of 170. It was the longest voyage ever attempted in search of a country. They reached the coast of Brazil, and from where they traveled to southeast. The winds identified by Bartolomeu Dias aided Gama and took him to the southern coast of Africa. However, Gama left the place due to disputes with the local government. He sailed past Mombasa and reached Malindi. On sighting Indian merchants there, he sought the help of the local navigator and set sail on 24th April 1498. With the help of the southern monsoon winds, he reached Kapad near Kozhikode on 20th May after a voyage of 23 days. But Gama struggled a lot when he tried to return during this southwest monsoon season itself, neglecting the advice of experts. It took him 132 days to reach Malindi. Children, due to southwest monsoon winds, Vasco da Gama reached Kerala in just 23 days. But he returned to Malindi. It took 132 days due to winds. Now, let's discuss in detail the different kinds of wind and the effects and the formation of the winds. Now, let's moving on to the next topic, variation in atmospheric pressure. Atmospheric pressure is the weight of atmospheric air. You already learned that. The average weight that air exerts on the Earth's surface is 1034 milligram per centimeter square. The average weight that air exerts on the Earth's surface is 1034 milligram per centimeter square. The atmospheric pressure is measured using an instrument called mercury barometer. So children, here is a question for you. Which instruments used for measuring atmospheric pressure? Yes, mercury barometer. Sit down. It is recorded in units like millibar, that is MB, and hectopascal, that is HPA. The unit record in unit like millibar, that is MB, and hectopascal, that is the units. The level of mercury at the normal atmospheric pressure will be 76 centimeter. Normal atmospheric pressure will be 76 centimeter. So the level of the atmospheric pressure at that point will be 1013.5 2 millibar or 1030.2 hectopascal, that is HPA. Got an idea? Children, notice the place marked A and B in the diagram. Which of these places will have a higher atmospheric pressure? Why? Children, now let's moving on to the next topic, atmospheric pressure and altitude. See, the atmospheric pressure decreases with altitude. ഉയരത്തിലേക്ക് പോകുന്തോറും atmospheric pressure കുറഞ്ഞുകൊണ്ടിരിക്കും. See, the pressure decreases at the rate of 1 millibar MP per an altitude of 10 meter. ഓരോ 10 മീറ്ററിനും 1 millibar എന്ന രീതിയിൽ atmospheric pressure കുറഞ്ഞുകൊണ്ടിരിക്കും. Isn't it? So, as one goes up, there is a decrease in atmospheric pressure due to rarefication of the air with the altitude. ഇപ്പോൾ ഒരാൾ മുകളിലോട്ട് പോകുന്തോറും അറ്റ്മോസ്ഫിയറിക് പ്രഷർ കുറഞ്ഞുകൊണ്ടിരിക്കും. നമുക്കറിയാം ഊട്ടി, കൊടൈക്കനാൽ, പൊന്മുടി ഇങ്ങനെയുള്ള സ്ഥലങ്ങളിലേക്ക് പോകുമ്പോൾ, അതുപോലെ തന്നെ നമ്മൾ ഫ്ലൈറ്റിലൊക്കെ പോകുമ്പോൾ നമുക്ക് ഫീൽ ചെയ്യാൻ പറ്റും, നമുക്ക് ചെവി തിങ്ങാവുന്നത്, ചെവി അടിയുന്നതായിട്ട് ഫീൽ ചെയ്യാറുണ്ട്. സോ അതെന്തുകൊണ്ടാണ്? അവിടെ അറ്റ്മോസ്ഫിയർ പ്രഷർ ഇല്ലാത്തതുകൊണ്ട്, കമ്മിയായതുകൊണ്ടാണ്. ക്ലിയർ? Then listen. The atmospheric pressure and the altitude are inversely proportional. അപ്പോൾ അറ്റ്മോസ്ഫിയർ പ്രഷറും ആറ്റിറ്റ്യൂഡും ഒന്ന് കൂടുമ്പോൾ മറ്റൊന്ന് സ്വാഭാവികമായിട്ട് കുറയും. സോ ദാറ്റ് ഈസ് ദി ഇൻവേഴ്സൽ പ്രൊപ്പോർഷണൽ. ക്ലിയർ? In this picture we can see a high altitude, so there will be low pressure. In this picture we can see the place B is low altitude, so we can feel here high pressure. Children, now let's moving on to the temperature and atmospheric pressure. Like any other objects, air also expand when it gets heated. Air also expand when it's heated. See, the expand air is less dense and hence it ascends. This lead to lowering of atmospheric pressure. So, the expand air is less dense and hence it ascends. This lead to lowering of atmospheric pressure. Listen, the ascending air spread to the sides. The ascending air spreads to the sides and it started cooling. It started cooling. On cooling, it becomes dense and descends. As a result, the atmospheric pressure increases. Clear? See, the atmospheric pressure and the temperature are inversely proportional. ഒന്ന് കൂടുമ്പോൾ മറ്റൊന്ന് കുറയും. ടെമ്പറേച്ചർ കൂടുമ്പോൾ അറ്റ്മോസ്ഫിയറിക് പ്രഷർ കുറയും. ക്ലിയർ? Now let's moving on to the next topic, humidity and atmospheric pressure. See, humidity refers to the quantity of water present in the air. അറ്റ്മോസ്ഫിയറിലെ വാട്ടറിന്റെ പ്രസൻസിനെയാണ് ഹ്യൂമിഡിറ്റി എന്ന് പറയുന്നത്. സി, വാട്ടർ വേപ്പർ ഈസ് ലൈറ്റർ ദാൻ എയർ ആൻഡ് ഹെൻസ് ഇറ്റ് അസെൻസ്. വാട്ടർ വേപ്പർ, നമുക്കറിയാം വാട്ടർ വേപ്പർ ഈസ് ലൈറ്റർ ദാൻ എയർ ആൻഡ് ഹെൻസ് ഇറ്റ് അസെൻസ്. അതുകൊണ്ട് അത് മുകളിലോട്ട് പോകുന്നു. സി, ഇഫ് ദി ക്വാണ്ടിറ്റി ഓഫ് വാട്ടർ വേപ്പർ ഈസ് മോർ in the unit volume of air, then the naturally atmospheric pressure will be less. So, humidity and atmospheric pressure are inversely proportional. ഒന്ന് കൂടുമ്പോൾ സ്വാഭാവികമായിട്ട് മറ്റൊന്ന് കുറയും. That is known as the inversely proportional. Clear? Children, Isobars are the imaginary lines joining places having the same atmospheric pressure. We can easily understand the distribution of the atmospheric pressure of any region by observing the isobars. In figure shows the distribution of atmospheric pressure of a region in two different seasons. Children, this is for today's class. Hope you all have understood the topic well. I will meet you soon with a new topic. Be safe and we will meet again. Thank you for being with me. Have a nice day. Be positive.